In step 2, we're going to answer the question, how do I convert my Proliner data into 3D surfaces? But before we do that, let's have a quick review. To make Better Marine Canvas faster, the process involves 3 easy steps. Step 1 is to capture your geometry, and for this, we use the Proliner by Protum. Step 2 is to convert your Proliner data into 3D surfaces, which is what we're going to do now using Rhino 3D. And lastly, for step 3, we will convert the 3D surfaces into 2D flat patterns using ExactFlat, 3D to 2D digital pattern making add-in for Rhino 3D. So let's get started with step 2. Here is the finished digitization of the boat. It follows the final desired form of the canvas to be fabricated. Each dot represents a point captured by the Proliner. Lines connect the dots. Our first step is to turn off the points, and then we can begin creating surfaces. The surfaces should be created such that they are analogous to the desired pattern shapes that will be sewn together. To do this, we will use the curve network command and the join command. To create a surface, we simply select lines which border or bound the surface we would like to create. Typically, the top, bottom, left, and right curves. The intersection of these curves demarcates an edge boundary for the surface in question. The surface thus generated is the pattern shape that will be cut and sewn. If we cannot create a surface with the desired shape, it may be yet necessary to use the join command in Rhino. In this way, we can select curves and join them together. When joined, the curves will represent the desired edge boundary of the correct pattern geometry. The lines must be contiguous or intersecting to create a surface. As you get better at digitizing with the Proliner, your steps in processing and creating surfaces will become more efficient. As you can see in this example, the line in question is not contiguous, and therefore we will use the join command to connect the lines and eliminate the gaps. Let's take a look again. Select the curves or intersecting edges of the pattern piece in question. Select them such that the curves are edge boundaries of your desired pattern shape, and then create your surface. If you cannot generate the desired edge boundary, as in this example, then you will need to use the join command to create a contiguously connected line segment that appropriately reflects your desired edge boundary. If you're dealing with a symmetrical part, then it is possible to mirror the surfaces created. This may save time, but it is a little bit beyond our demonstration today. For this example, it is clearly symmetrical in certain areas and would be a good candidate for creating surfaces by mirroring those that have already been created. If you want to know more about how to create your patterns even faster, reach out to us and we'll show you how. Another technique for improving your ability to make Better Marine Canvas faster is to use a GrassHopper script to automate or semi-automate the creation of your surfaces. GrassHopper is a block programming language for Rhino 3D. We know of some users, like John Rickards from Dockside Canvas, that have implemented their own GrassHopper scripts to significantly improve the speed of creating perfectly accurate and well-fitting marine canvas projects. Now, GrassHopper is an advanced technique, but it is well worth the effort of implementation. Now that we have covered the techniques for going from the point network to curves to surface creation, let's skip ahead to the final result. We are now ready for step 3. Again, let's take a quick review of the process so far. To make Better Marine Canvas faster, the process involves 3 easy steps. Capture your geometry, step 1. For this, we use the Proliner by Protum. Step 2 is to convert your Proliner data to 3D surfaces. We showed how to do this with Rhino 3D by creating surfaces from the point and curve network generated by the Proliner. And lastly, we'll convert the 3D surfaces into 2D flat patterns using the Exact Flat 3D to 2D digital pattern making add-in for Rhino 3D. Let's get started with step 3.